you. Now we discuss Kepler's laws. Actually, this part is coming in gravitation. Johannes Kepler is the one who observed the planetary motion around the sun, and based on his observation, he arrived at certain conclusions, and those conclusions are called Kepler's laws of planetary motion. Basically, there are three laws, and we have to define all the three laws and the basic behind it. The first law of Kepler is called law of orbit. This law states that a planet revolves around the sun in elliptical orbit, keeping the sun at any one of its foci. Now see, this is an ellipse. Elongated circle, in short we can say. And for the ellipse, there will be two focal points on either side of the minor axis. The lengthy axis is called major axis, and the shorter axis is called minor axis. Now, according to the first law, a planet will be revolving around the sun in elliptical orbit, keeping the sun at any one of its foci. So F1 and F2 are the foci. And let me consider for the planet, the sun is occupying this focal point. Okay? So for every planet, there will be an elliptical orbit of its own, aligned in the three-dimensional space anyway. And the sun will be occupying any of the focal points of the ellipse. Okay. Now, the second law. Second law is called law of area. Law of area states that the radius vector drawn from the sun to the planet sweeps out equal areas in equal intervals of time. Okay? Now, what it refers to is, at an instant, let me consider the planet is here, and the radius vector will be the line joining the planet to the sun. And if I start a stopwatch and I fix a time duration delta t, within that delta t time, the planet moves from here and suppose it reaches up to this point. So the radius vector will be describing an area of this much. Radius vector sweeps out an area, let that be delta E. Now, if I consider the planet moving around, and after some time the planet is reaching its farthest point or moving away from the sun, then let the position of the planet be here for the time being. And after a time delta t second, same as this, the planet should be reaching somewhere here. Then, if I draw the area here, the area swept by the planet, the radius vector, area swept by the radius vector is here also, it is found to be delta E. That means if you fix the time duration constant, then the area swept by the radius vector as the planet moves will be found to be the same. Now, based on this fact, we can define a quantity that is delta A by delta T remain a constant for the planet, and this particular quantity is called aerial velocity of the planet around the sun. So in short, the second law implies that the aerial velocity of the planet around the sun remain constant for a given planet. Okay? Now move on to the third law. Third law is called law of period. Law of period. Third. Law of period. Now, what this law says, let's see, that the square of the time period of revolution of the planet around the sun is directly proportional to the length cube of the length of the semi-major axis of its elliptical path. That means cube of the length of the semi-major axis. So semi-major axis, let me take, is A. Then, as per the statement, we can get T square directly proportional to A cube. Okay? So if you are interested, you can have the proofs while discussing the other parts in gravitation. Time period of the satellite moving around and all those things, you will be getting a result somewhat like this. Now, the elliptical motion, you can see that the planet will be coming very close to the sun and further away from the sun. So, the movement of the planet around the sun is not a constant, not with a constant speed. When it nears the sun, the speed will be increasing. When it is moving away from the sun, the speed will be decreasing. But one thing you can specify that for the planet, the angular momentum of the planet remains constant in its orbit. Okay, so these are the three laws you can consider, and one more thing, that this semi-major axis, for the solving of the problem, you can assume it to be the distance from the sun to the planet approximately. That is another fact to be remembered. Alright, so these are the three